salmonellas of E. coli was posing a human health problem to the workers in the zoo. Komodo dragons are very neat and tidy. They have one corner of their cage that they use as a latrine. And so an area like this is where they always go and do their poop and their pee. And it gets extremely high in human pathogens. So not just E. coli, but a number of the other human pathogens, Salmonella, Shigella, and Pasteurella Legionnaire's disease is something that these guys carry. You have to be really careful with these animals because their saliva contains enzymes that will chew through your flesh. And of course, it's all these wonderful bacteria that is carried in their saliva. So it's a hazardous pay to have to go into these cages. And of course, the cage is maintained at about 105 degrees at about 95 to 98% humidity. So for a human being, it's just a horrible place to have to go in and do work and clean the cage out. But once a week, they were having to send people in to basically dig out all of this sand rock mixture, carted out about 4 wheelbarrows full of material, take it out, and then they have to dispose of it, and then they bring back in fresh and fill in the latrines so the animals would be able to live in relative cleanliness. And so a lot of money, and so when Park Zoo came to us and said, we heard Elaine talk about you can reduce the number of E. coli, you can deal with this particular problem, is that true? And we said, yeah, that is true. So a situation like this, we should be able to apply good compost tea, this whole mix of microorganisms, start building structure, be able to compete with, inhibit, consume the E. coli with the whole mix of organisms in the soil food web. So I probably wouldn't choose here to use something like lactobacillus, because while the lactobacillus might be able to take out some of the pathogens, that's inadequate sets of organisms to build all of the structure for an ongoing long-term benefit in building structure and keeping oxygen moving into that soil material. So what we went in and did, so Matt Slaughter, who's the head of Oregon Food Web, which is the SFI lab in Oregon, he arranged to make the tea, make sure it got sprayed in this corner of the cage, and while they were at it, they did the whole thing. Why not? You have to be really careful with the animals. They were concerned, was the effect of compost tea going to be on the Komodo dragons? Didn't think there was going to be any. So went in there. So we have the data we were looking at before we applied the tea spray. Here's the typical E. coli levels. When you realize that when you're down around 500 or 600 E. coli, you're at the limits of what's acceptable in the regulatory world, and when you're dealing with 4,300 E. coli per gram of soil, you're in serious trouble. There were only bacteria in that food web, nothing else present. This is a mean of 3 samples, and not much variability between samples. So then we applied the compost tea, and then went back in about 2 weeks later, and we found absolutely no E. coli. We had established fungi, protozoa, so how fast could you get this stuff established in your soil? Very rapidly, especially if you're dealing with this sort of situation where there's no decent biology in that soil. But we're putting in a lot of humic acid to help these organisms survive. Question?
March 5th to April 1st, 3 weeks, how many applications?
Just one. So there was one application just after this, so it would have been like March 15th that the first application of compost tea went in.
And went down to 0.
And yep, absolutely no detectable human pathogens. And we're starting to build that food web in there. And then 2 weeks later, they take another sample. So I'm just going to summarize all the way through the rest of the summer. We were taking samples every 2 weeks, and all of the data looked like this. No discernible E. coli all the way through until September 15. And this is the first time then that we detected E. coli in any of the samples. So instead of having to go in and deal with this problem on a weekly basis, Seattle Woodland Park Zoo is figuring that it's at least 6 months. How much money have we saved them? Because you don't have to pay somebody hazard pay in order to go into this cage every week. We go in once every 6 months. They have changed from having people go in and do the sprays by hand. The irrigation system that they have in the cage anyway, they're just putting the compost tea in through the irrigation system that goes in the cage. Hasn't hurt the Komodo dragons at all. If anything, it's improved some of the scaly patches that they've had on their skin by treating them with the compost tea. So another example of what do you do to figure this out and showing that it really does work. Questions?
Yeah, I was just wondering, so they didn't take out that wheelbarrow loads of stuff anymore. They just left it all there, they compost tea. Excuse me, how many times? Once a month?
They only spray once, right?
Once. They only spray once.
And then they put it back in 6 months and respray.
What this data indicates is, 6 months is all that first application of the compost tea would continue to deal with the problem. Of course, the manure in the corner, well, but it's decomposing. The microorganisms in the compost tea are decomposing that material or essentially composting the manure that would otherwise be building up in the corner. At a certain point, enough buildup of the manure that we're not taking care of the problem, but we're dropping the requirement from going into the cage from once a week to once every 6 months. And of course now they're starting to apply the compost tea anytime they think they need to through the irrigation system. So we probably do need to go back and talk with Matt about what's the actual story going on now. But applications of the proper biology dealing with animal food. So here's the situation with the landscape. So this is work that we were doing with Boston Tree Preservation and Safe Lawns up in the Boston area. This is the Boston neighborhood. This yard looked like these yards a year ago. So brown, all the grass is dormant. When you look at these yards, what are the green plants that are growing? Those are the weeds. So despite the fact that these people were putting on the maximum amount of water that they were allowed, their lawns have turned all brown and not looking really great. Almost every plant that you look at on the street, they are all being damaged by disease, insect pests. Everything in any of these lawns are showing problems, diseases or insect pests. None of the plants in this yard have any problems with the insects or the diseases, and the backyard, the same thing. They have a nice garden at the back. So just how do you do this process of converting? In that particular lawn, we have not watered that lawn at all through the whole entire growing season. The natural rainfall has been more than enough to supply the water for that particular lawn. Well, how far down are the roots going? Well, in the other lawns, the roots are going down just maybe 2 to 4 inches max. In that lawn, the year after we started working on this lawn, those root systems are down at 5 to 6 feet. So you get your root systems down that far, you don't have to water. So in a dry climate, or in this particular year, there was watering limitations. You could only water your lawn once every 3 days, and you could only put an inch on. So of course, the police look at that lawn and go, oh, we know you're watering your lawn. We know you are. When are you doing it? We're going to give you a ticket, and we're going to hand you that fine. So there would be police cars hanging out around their property to be able to hand them that fine, because they just knew they were watering their lawn at 2 o'clock in the morning or something.
Didn't check the water meter?
I don't, that's the police for you. And maybe the police thought that they were doing something to disconnect their water. I don't know, but they had to stop and watch and make sure that they weren't. So it was kind of a fun part of this and stuff. So exactly what did they do? How do you take a lawn It looks like this. It's got some diseases, it has some weeds, and convert it into that. What is the process? So, again, it's kind of what we've been talking about all along, but this time I'm going to make you look at data. So we went into that lawn, so let's say if we wanted to start with one of these other lawns, the first thing we would do is decide where we want to take samples. So if we're looking at the lawn, we would take a number of samples all the way around the house and the lawn area. We will probably go into the area around the trees, halfway between the stem and the dirt line of the tree. We would be taking samples from the little shrubby things on the flower garden beds and their vegetable garden in the back. We would want to be taking samples and look at what the biology is in all of those areas to start out with. So we're looking at a fungal bacterial biomass ratio here. So we started out with 5 micrograms of fungal biomass per gram of soil, 300 micrograms bacterial biomass per gram of soil. What we need for the growth of that really good bluegrass, bentgrass, fescue lawn, we need 300 micrograms of fungi and 300 micrograms of bacteria. So can you tell me what this soil is lacking? Yeah, we have a boatload of fungi to get back into the soil in order to get that balance going. Protozoan and nematodes. This is not phosphorus and nitrogen. Protozoa and nematodes. That balance. We had absolutely no protozoa at all. Couldn't find them. And all of the nematodes were root feeders. 4 root feeding nematodes per gram of soil means most of your productivity is going to the nematodes. And you're going to have bare patches, you're going to have parts of your lawn that go dormant very rapidly because the grass can't keep up with the consumption by the root feeding nematodes. And there was no difference between the grass, the trees, the flower beds, anything in the garden. The soil looked the same throughout this whole area because they basically didn't pour on pesticides, inorganic fertilizers, and it does a real good job wiping out your biology and helps select for those root-feeding nematodes, which we have a really abundant level. So now how do you fix that? Get your compost. Let's look at the compost that they have. 250 micrograms of fungi, 300 micrograms of bacteria. So we're a little lacking on the fungal component. So when we put this compost out at 1 ton to the acre, so on that whole lawn, we put about 10 pounds of compost spread along, over everything. So it's about 1 ton per acre is what we were putting out. We were lacking fungal biomass, so we added humic acids in order to encourage the fungi. The protozoa in that compost were about 20,000 protozoa, so yeah, we should be able to increase that protozoan population. There were no nematodes in that compost. So, oops, we're not going to be able to bring those nematodes back because we're not getting them put into the system, at least through that compost. We put mulch under the trees and the shrubs because that's fungal food. We put mycorrhizal spores in with this compost tea to try to get the, put it in with the compost to try to get mycorrhizal colonization growing on those plants. So that was in the fall, all winter long for this biology to do its thing, improve the soil, so come the next spring when the snow melts, let's go out and grab a sample of the soil and see how much we improve things. So come springtime, 150 micrograms of fungal biomass. Is that an improvement? Is it where we want it to be? Look at the fact that we also improve bacteria. So, you know, that ratio is really not much improved. And at least we got some better fungi in there, but still wildly out of whack in the weed end of the picture. We did get protozoa in there, so at least there's no screening need to put inorganic fertilizers out here because we do have nutrient cycling. What if these numbers had all been 0 come the next spring. If the grass was already growing here, I would have been saying, let's get those inorganic fertilizers out there, because we didn't fix the biology, and we got to keep that laundry. And that's what your client insists on. So we would put perhaps a small amount of inorganic fertilizer, or we might put fish hydrolysate down, because that fish hydrolysate would help select for the fungi, push the nitrogen out that your plant requires. But we got the protozoa back in there, so not to worry. Now, we had some bacterial-feeding nematodes. Where did they come from? We didn't add it in the compost. Where did those bacterial-feeding nematodes come from? Well, because we got some real good bacteria in there, and it probably attracted it from other places. So those bacterial-feeding nematodes are starting to move in, which is good. Yay! A little bit more nutrient cycling going on. Have we fixed the problem? We're not set the stage yet to grow the grasses we want to grow. We've got more work to do. So what are we going to do? We took the compost that we've been using before, or at least these people took the compost that they've been using before, they made the compost tea and they applied it. And then we looked at the compost. Should they have bothered applying that compost tea? Here we have the compost. Remember what it was back in the fall? That wasn't too bad, was it? That ratio's not too far off. But what's happened to the compost through the winter time being stored in their facility? Look at what's happening. This is horrible. The fungi have decreased a little bit, but look at those bacteria. Wow! So this isn't even close to the balance of fungi and bacteria that we want to have now. People seem to take the attitude that, well, I measured this in my compost and it's just going to stay that way forever. If you measured it last fall, you better be measuring it again now when you're going to be using it. Because really, they did not store that compost correctly. They needed to have been making certain that those fungi stayed alive and happy. So maybe some more fungal foods needed to go in there. Something to keep those fungi alive and happy. Protozoa have dropped way down. Well, that's probably why the bacterial numbers are up, because they're not being eaten. We do have bacterial and fungal feeding nematodes in the compost now, because they stop turning it all the time. Is that why our fungal numbers have gone down? Bacterial, so it's sometimes a little hard to figure out exactly why you see increases and decreases. It doesn't always match up. But bottom line is way too bacterial, not enough protozoa. At least we got some bacterial and fungal feeding nematodes. So we're going to make tea out of this. What does the tea look like? What kind of plants are we going to be growing by putting this tea out on this property? Weeds. Yeah. Why aren't we bothering? No protozoa in the tea, so not enough here, and maybe their brewer isn't good enough to extract and get those organisms into the tea. No nematodes into the tea either. So, recommendation, if they had just looked at this before they merely put it out, they would have known that we should put good fungal foods in that compost. They should have added a protozoan infusion into the system. What's a protozoan infusion? How did I know you were going to ask that question? So what's a protozoan infusion? What we're going to do is take a bucket, typically, or a large, whatever size container you want to take, and you want to cover the bottom with material that has a lot of cysts of your flagellates and your amoebae. It's a great way to store your protozoa is find a source that has really good flagellates and amoebae, so typically straw, dried materials that the protozoa could have climbed up the stem, eating the bacteria grown on the stem of the plant, and then as the summer dries out, they go dormant, sitting on that stem, sitting on the leaves. So now you've got a source of preserved or dormant protozoa on that leaf material. You take that, you just barely cover the bottom of your bucket with that plant material. And then you fill up your bucket, because that amount of water to the amount of plant material with organisms on it, about the right ratio. You don't want too much here, because as soon as you put water in here, the bacteria start growing. They're dormant too. They went to sleep. They're on that plant material. As soon as it's not got water, those bacteria wake up and start chewing on the sugars and the proteins that are still left in that plant material. As the bacteria start to grow and you get lots and lots of bacteria in here, then the protozoa go, hey, look at that. There's something to eat. So I'm going to wake up and I'm going to start eating all of those bacteria. So at about 24 hours, you get some really good bacterial numbers. Protozoa notice that, they wake up, so at 48 hours, your protozoa numbers should be taken off. So you might want to be checking this protozoan infusion. At 24 hours, make sure you're getting good bacterial growth. Another 24 hours later, make sure you're getting really good protozoa. So then this liquid goes into your compost tea. And so you will be adding the protozoa from the compost tea, excuse me, from the plant material into your compost tea. So now we artificially, if you will, put some really good protozoa in there. What we wanted to be looking at our tea and realizing we have no protozoa, and then quick brew this up, or I have this going already, so we can add those protozoa in there. Question?
Yeah, quick question about just this whole system about water, because it seems like you get too much water in the soil, your microbes die because they suffocate. But here, is it just because it's a short time, 1-2 days, that they're okay, they propagate, and they go, oh, we're happy with this before we die?
Which is why we're not putting too much food resource in there. Yeah, what if we filled our container up halfway with this plant material? And it would be a mess in about 5-6 hours. So this plant material, you want just a bare minimum. Bacteria have something to grow on, protozoa eat the bacteria, and this typically doesn't go anaerobic. What if you start noticing scuzz or scum or not so wonderful? Go get an air pump. So people will do that, go get the air pump, so just a little guy, and just put that tubing, maybe use a suction cup for the bottom of that, so you hold the tubing in the bottom, so now you start that aeration within that system. And how much aeration do you have to have? Just enough that you get the water to move, stays aerated. There's a lot of people in this world that get all bent out of shape about how big are the bubbles. The smaller the bubble, the better exchange rate with the water. Now, since really tiny bubbles are really good versus larger bubbles versus larger bubbles. Look, guys, this is not the important thing. This is someone's trying to hand you a line or make things, oh, you have really tiny bubbles. What are we really trying to do by putting that aerator at the bottom of the bucket? We're trying to get movement of the water because it's the exchange at this surface where most of the entrainment of oxygen comes from. This is insignificant as compared to this. So, you know, don't believe me, go talk to the engineers at the aeration store, guys online about what's the most important part of this. Bubble size, no big deal. How much are you getting this surface moving and mixing? That's what's important.
How much protozoa infusion for compost tea is like a 5-gallon bucket?
I would probably just take everything you made and throw that into your compost tea.
But how much compost tea?
It would depend on how much compost tea you needed to put into your soil.
If it was 100 gallons, it'd be okay.
Yeah, you'd get the protozoa in there. Now, if you were doing 1,000 gallons, you would probably want to do, you know, like 10% or 1%. Excess organisms going into your soil is no big deal. If there isn't something for them to eat, they just go to sleep. So, excess, perfectly fine.
And the plant material at the bottom, Is that any kind of plant material or something that's just, or I didn't quite understand what they're.
You typically want to be looking for organic plant material because the pesticides and inorganic fertilizers wipe out these organisms on those surfaces. So we want to be going for organic material. The grass in your yard, after you mow it, let it dry down, should have a really good set of microorganisms on there. So how do you make sure? Take a little bit of your plant material, just rake up those lawn clippings, put it into something that's going to keep them dry. Take a handful of that, put it at the bottom of the bucket, 24 hours, check your bacteria. No bacteria? Okay, then go find a different source of plant material because that's not working. At 48 hours, take a look for your protozoa, for your flagellates amoebae. Are they there? If they're not, go find a different source. So organic hay, organic plant residue of any kind usually works really well. FAC stands for the different groups of protozoa, flagellates, amoebae, ciliates. It also stands for Friday Afternoon Club, where we all go drink beer.
And we look at microscopes.
After all day, we have Friday Afternoon Club. Okay, so this tea was really not worth the time it was taken up to put it on. They just charged into it without checking, so they wasted their time. But I still want to look at 2 weeks later. What's the effect been of putting that compost tea on? Has it actually benefited? Every once in a while, I still get surprised. So 2 weeks later, we take a look, and here's our ratio of fungi to bacteria. At least the fungi from the compost still growing, still improving. But dang it, bacteria are taken off faster than our fungi are. So we're still very bacterial. We're not setting the stage for grasses to grow. Protozoa didn't increase at all as compared to the last time we looked at this soil. Still only have bacterial feeding nematodes. So it was a waste of your time to put that on. So now let's go into May. So a month after the last application. Again, look at the compost. The fungi are getting worse. Protozoa come up a little bit, but I'm not impressed by that number. Bacterial feeders, fungal feeders, yeah, we got them, but at this point, I could say because they finally learned to test the compost before they did anything with the compost tea. Now I can say you really, really have to put fungal foods in here. So they put some fish hydrolysate, they put some humic acid, they put some oats, steel ground oats in here, some good fungal foods. And so here we are, this is about a week later. Look at the difference. Our fungi are up to where we want them to be. Our bacteria come right down. As your fungi start winning in competition with the bacteria, your bacterial population is going to drop right down. So yes, we finally have a compost that's worth making tea out of. Our protozoa come right up as well. Yeah, but we lost the nematodes because we had to mix those foods into the compost. So we got more of what we have to start with. Later, as we leave that compost alone, the nematodes will come back. Please come back. So we made compost tea from that compost. Their brewer is just not all that wonderful. Because while we have good fungi in the compost now, it didn't get through into the compost tea. So at this point, after a couple times of this fairly disappointing compost tea, they're starting to believe me when I say, I think there's something wrong with your brewer. And you need to start paying attention to it. So let's take a look at your brewer. Walk over to their brewer. Outside, beautifully clean. Inside, and it's like, oh my God. This looks like the inside of your, the oven after you forgot to clean it for 2 or 3 years. It was all black and scuzzy inside. What happens to your really good aerobic organisms when you're growing them in an anaerobic nightmare? Okay, so let's learn to clean things. And when we're talking about clean, we mean girl clean. Girl clean. This must pass your grandmother's white glove test. So look inside that brewer. If there's our lines of yuck around the top, you're going to have to get in there and clean it. If you've got a drain down on the bottom, you got an opening someplace, you're in there with the toothbrush, cleaning that out. Now it's really easy to clean most tea brewers. As you start to drain the tea out of your brewer, get your high pressure washer and blast that scuzz off the side. When it's still wet, it's really easy to get rid of. Right on through. You diluted your tea a little bit. Right, well, we're going to dilute it anyway to apply it. Typically, we're going to use water as a carrier to apply it anyway. So, blast that stuff off. And then as that finally goes out the bottom, wherever your drain is, you blast that opening with your high pressure water. And you clean out the brew. You have to stand there and watch the tea go out anyway, didn't you? When is it out? So just be clean while you're doing that. We'll go over this more on Thursday, but you do not have you don't have those like air stones in there. Never. You do not ever, never, I said it enough times, never have air stones in a tea brew. I don't care that you take an air stone off and you put it into pure hydrochloric acid or bleach that's 100%. You cannot clean the inside of an air bubbler stone. It is anaerobic in there. You've got anaerobic organisms growing in the little spaces between the sintered glass. So you don't ever use anything like that. Any pipes, any stuff inside your brewer, you must clean every inch of that. Every centimeter has to be cleaned. You got little disc diffusers on the bottom. What's the scuzz happening on the bottom of that disc? You got to take those discs off. You've got to look at the bottom side, and you have to clean any anaerobic biofilm that's growing on the surface of whatever you're looking at. So see, I don't like anything inside my tea brewer. I want nothing because I hate to clean. I really do not want to spend any time at all with a toothbrush cleaning something from inside my tea brewer. I have way better things to do with my life. Me and my high pressure washer. I can't blast it off easily. I'm not interested in that tea brewer. Go buy a different tea brewer.
You have to make sure you have one chlorinated water source, don't you?
Right. So when you're dealing with the water that you're going to be brewing with. Now, if you've got chlorinated water, how do you deal with the chlorine or chloramine in that water? Add humic acid. Most filters do not take out chloramine. So you've got to have special filters, and they're expensive, and you have to constantly replace them. Way easier, just add a little humic acid into your water when you start your tea brew. Before you put your organisms in there, add the humic acid. Where are you going to buy humic acid from? No. You make it yourself. So, you add a little extra fungal food in there. How do you know you have enough humic acid to complex all the chlorine and chloramine? You have to wait until you get a brown tinge to the water. You need excess humic acid. So you're going to stand there and add your humic acid until you start seeing a nice brownish tinge. Your water turns from clear water to like that color right there, a nice khaki color. Be perfect. So you complex all of the chloramine. Now, humic acid is only going to complex the chloramine for about 2 weeks. That you're safe. Okay? Question? No?
So we have dishwater that we do surface runoff, which has that kind of yellowish, golden brownish color. Is that humic acid?
No, that would be fulvic, probably.
Be what?
Fulvic acid, and it's not capable of complexing there is no data, let me put it that way, no data that I've seen that fulvic acid is capable of complexing the chlorine. You might be okay in complexing chlorine. But chlorine's a gas, and typically just by bubbling, running your air bubbler, your aeration system if you get rid of the chlorine. But most municipalities are starting to put chloramine into their water because the chlorine just does not cut the bill anymore. We have some really nasty E. coli. E. coli 0157H. Nasty. How do you get rid of it? Chlorine doesn't touch it. Gotta have chloramine. So, most places are now adding chloramine into the water.
But if we're using our ditch or ag water, then we're not coming into contact with chlorine.
What else could be in your ag water? Yeah, so would it be a good idea to complex all that garbage that's in your water? Pardon? Catchment? So if it's not going to go through somebody else's field, as long as there's no way for contamination to occur in that water, and I deal with a lot of water here in Hawaii, where yeah, it's going into a catchment, but it's going through somebody else's agricultural field and picking up all kinds of horrible stuff. So,
Rainwater.
what's your roof made of? Tin?
Yeah,
Yeah, so chloramine, there's two compounds on the tin. But you're gonna have to complex those two things. Add humic acid, and it complexes those things. So I always figure it's safer to add the humic acid because almost everything, salts, chloramine, chlorine, garbage, other not so desirable. Now, if you've got pathogen contamination in your water, no, humic acid's not going to deal with that for you. Some attention to water quality is really good.
Is this going to be covered in the handout that you'll be using?
Yep.
And what about stream water that's stored in plastic tanks? Does it have the sediment and things in the stream, stored in the tanks? Is that going to go anaerobic or what happens there?
As long as there's not a lot of organic matter in that in stream water.
Yeah, like leaves and things, but like fine, like mineral sediments.
As long as it's just mineral material, microorganisms can't use that to grow one. So yeah, that's fine. It's probably not a problem in those things.
So that's like clean water to use for your compost use.
Yeah, but I would still throw some humic acid in there as you put it into your tea brewer.
Yeah, so it's always, you're just saying always humic acid.
It's a safety factor. It's
Okay.
hedging your bets a little bit. What's wrong with that? Especially when you're making your own humic acid. This is not costing you much of anything. So why not? Be a little bit more on the safe side.
Do you need to let it set?
Pardon?
Do you need to let it set in the humic acid, or do you immediately?
It's an immediate reaction. It's practically instantaneous as far as discussing these things with engineers that ought to know really fast. Just remember that humic acid does not keep it tied up forever. The biology is now going to have to come along and chew on it, and that's what really ties it up into the structure of the organic matter. Things bind on humic acids. This absorption phenomenon only lasts for about 2 weeks, and then there's release.
How do you guys make your humic acid?
I just passively run water through my compost. Cheap. Yes, I am the world's cheapest and most lazy gardener. So come on along with me. It doesn't cost much money. So, let's go back and take a look at that brewer. So, what's wrong with this thing? We had to add a protozoan infusion into this because we had no protozoa. What happened to the protozoa that were? Well, the brewer was a mess. So, they applied that compost tea. They got it out before I went, we got a problem here. So, at least we're starting to see an improvement. At least we got some good fungi out there, and it is starting to grow. Still not quite where we want it to be. Much better levels of protozoa because we put the infusion into the tea. We didn't get the protozoa in the tea itself. We added the infusion. We got bacterial-feeding nematodes in our soil. Oh, that's good. So now, this is starting to feel a little disappointing, isn't it? We put in compost, we put in 2 compost tea. Yeah, but it's because there's been production problems with the compost tea. So now, here we are, a whole month later, those fungal foods. have been in the compost for a month plus, and now, look at this. Yes, we are really going to be improving that fungal complement in our soil. And this compost, turn it into a tea. We got okay levels of protozoa, but still I'm going to want to add a protozoan infusion into this probably. So now here we are with the compost tea. Yes, finally. When we put the tea out, we're going to add humic acids when we put this compost tea onto our trees and our shrubs. So we're putting out the fungal inoculum. We're going to encourage them to grow once they get there. Pretty good protozoan levels because again, through the protozoan infusion into our tea. We've got the bacteriophagy nematodes in the tea now finally because we've got lots. 2 weeks later, we go in and look at our soil. Perfectly balanced for the grass. There's no need to be putting any more compost tea, anything else in this system. So June, we finally got this grass, this lawn to where we wanted it to be. Because we added fungal foods around the shrubs and around the trees. This is finally balanced properly for our shrubs, balanced properly for the trees. We've got good protozoa, we've got bacterial-feeding nematodes, fungal-feeding nematodes, and predatory nematodes in that soil. Yes, we finally got there. But couldn't we have gotten there back in April? If we had checked, if they had checked the compost to begin with, and made sure that that compost was up to par right from the very beginning, we could have exited 2 months of aggravation. So, microscopes, are they important?
See.
So, maybe you don't have to keep the microscope forever, but that is so useful to just quickly looking at what's really going on in your compost and your teas and your extracts and your soils. So just a review, if you're going to do a project, think about looking at the organisms before, looking at the organisms in the compost and the tea. 2 weeks after you add anything, check and make sure that that application did some good for you. Pictures of the property all the way through. Notice that I have not been able to give you pictures of the property all the way through. That would sure be nice. Some work then at James Satillo. So this is a lot of work that coming up here that's from James Satillo. It's a company Outline.com. Treewise in New York is another company that he's worked with for a long time. This is Brooklyn Bridge Park. This was engineered soil just a couple of months ago. So this was installed in April. And here we are on the 4th of July. And look at the grass. They had, 8,000 people sitting on this lawn the previous night. And has suffered no damage. Of course, we went out and we made sure to put a compost tea on this soil after it's been well hammered by 8,000 people enjoying fireworks from the Statue of Liberty the night before. It's not coming out really clearly on this particular picture, but they had the Coca-Cola stand right here, and you can see some of the damage from them dumping Coca-Cola on the ground. So yeah, Coca-Cola, what is that stuff?
Acid.
Phosphoric acid. Let's chew your teeth out. So it does have a bit of an impact. I think this is where they had the elephant ears, so there was a frying oil. Yeah, look at the damage from the booths that they had out there to feed the people, but that comes back right away and don't have a problem with it. So an area where they put trees in, so Brooklyn Bridge planted, these trees were planted in April. Here we are in the middle of a drought. There is no irrigation on certain parts of this lawn, so it's growing, doing perfectly well. So ponds. Typically a pond like this come mid-August would be green scum on top, right? It would be turning over. Very typical. But we have used no pesticides, we've used no inorganic fertilizers on this lawn. I'll show you in just a minute how these things are installed. But Typically, the engineered soil goes down, compost tea on top of that, the sod goes on top of that, compost tea, and then that compost tea once a month for the next 3 months, and that's it. Off and running. No pesticides, no inorganic fertilizers. So no runoff of the phosphorus or the nitrogens into the pond, and we do put compost tea into the pond to make sure that we have the good predators in the system that will be consuming the cyanobacteria that usually are the blue-green algae that cause the ponds to turn over. So you can still see the bottom of the pond. Even in the middle of August, there's no bad smells. As I was mentioning before, in Battery Park City, we were already working with T. Fleischer and his group at Battery Park City, the Park Conservancy, before 9/11 happened. This particular part of the park, all of these trees were defoliated because they were buried 5-6 feet deep in the drywall. Drywall is calcium carbonate, it's a salt. Gypsum, it's a salt. So buried, and that salt effect defoliated all of the trees in Battery Park City, all of the shrubbery, the grass, everything. Severe salt impacts from that going down. It took several weeks to clean that material off. The 6,000 trees that weren't destroyed or harmed or pushed over by bulldozers or things like that, we recovered all except 6 of those trees. The recommendation from the arboricultural community, from the landscape community, was that we should just cut everything in Battery Park City down, because it was dead. And that's how your standard conventional people would have dealt with the problem, was to replant everything. Instead, we started putting compost tea down around these trees, and we've recovered all of them to speak of. Only lost the 6. So think of the savings to the taxpayers of the state of New York. 6,000 trees. So we have had to replace some of the understory, so we replanted that understory this year. T. Fleischer is working on one of the apartment buildings that was destroyed in 9/11, and the design is to have a composting unit on the bottom floor. Everybody who lives in those apartments in that building has to bring their compostable material down to the composting center. All of the food waste from that apartment building is going to be processed in that composting center, is being processed in that composting center. The people in that apartment building, if they want it, they can get for free the compost that's being produced. And so a lot of them have green roof areas, they have balconies, they have outside areas that they're growing their own food. So on the top of that apartment building, green roof. So all done just with compost. Battery Park ball field, in the wintertime, they put up a ring, so the wood goes up and all that big equipment that comes with it. And they flood that area, and so you've got several tons of frozen water on the surface of this ballpark through the whole entire wintertime. How compacting is that? Think about, especially when your soil's already wet, and then along comes the water frozen, and now you got all those ice skaters skating across it. Springtime, all the water melts into your soil. Except we've got really good structure built by biology in this ballpark. We come in immediately then with a small amount of compost, so 1 ton per acre. I forget how, this isn't a full acre, so it's not a full ton of compost that goes on here. But making sure it's got the right biology in it. And then typically 3 applications of compost tea just to bring things back up to normal. The infiltration rate on this ballpark is 2 inches in an hour. Infiltrates in, no problem. You can be right back out there playing. So I've never seen a situation where, because a game has been called for rain, once the rain stops, you can be back out on this field in 20 minutes. So huge in terms of keeping the schedule on time. So an example then of exactly what we do in these kinds of systems. This is engineered soil. So all of the soil here, they dug out where the pond's going to go. Re-engineered. You know how the landscapers are. I don't like the hill here. We're going to put it over there. And then this is going to be the bottom of the pond. So now I want that hill over here. I want that flat area over there. And I just have to rearrange everything. I can't just leave it. Oh, okay, not going to do it. So then engineered soil. So this is two specific specifications. Exactly how much sand, how much silt, how much clay put into this engineered soil. They adjust the pH by running acid or base through that soil. I myself would call this dirt. It's engineered dirt because it has no life in it to begin with. It doesn't really have any organic matter to speak of in it. So this is what we start with. How are you going to fix this? Because, oh yeah, imagine how your sod's going to do on this material that's really high in salt. I love it when you talk to the people who design this. Now, normally, when we're looking at the growth of grass, you don't want more than maybe about 100 microsiemens of salt, electrical conductivity, per cubic centimeter of your soil. That's normal. Anything over this, and I'm just going to be going nuts weight on this. So in this engineered soil, it's 10 decisiemens per cubic centimeter. So most of you are going, so what? That's 100, that's 10. Oh, look at the units. This is 10 to the minus 6. This is 10 to the minus 1. This is a serious salt problem. But they try to disguise it because most of the general public has no idea what the difference between the units means. We don't want more than micro amounts of salt. And this has got a good 10 to the 5th times more salt that's allowable. Yeah, so it's painful. So what are we going to do with this? How do we get rid of that problem? So as I described, the first thing we're going to do here is just inundate this with as much compost tea as we possibly can. So get it really soaked, whatever you have to do to get that nice and 50% moisture into that soil. That goes down before the sod. Sod goes on top of that, and then on top of the sod, we're going to go in with a good application of compost tea. Now, you can see the sod itself has no infiltration. Because with just a few passes of our hose spraying the compost tea, this sod is already puddled. So it has no ability to allow water or oxygen through the sod itself. So we've got to rebuild that structure immediately, right away. That sod has been raised on chemicals. So we have to very rapidly switch this over into a biological system, and there we are putting biology on. A month later, we typically come back in, another application of compost tea a month later. You have to prevent people from over-watering the sod. That is probably one of the biggest problems. And you must convince them absolutely not to put any inorganic fertilizer on this system. If you put inorganic fertilizer in the springtime on this, it just makes the sod go dormant. Totally brown, goes absolutely dormant. Really ugly. So remember this was a sod? Can you see the sod layer in here? Right along there, that's what was put down. This is 6 weeks after that sod was put down. Look at how much the roots have grown. Those root systems are already down at 6 inches. 6 weeks, 6 inches. So through the course of the summer, those roots just keep growing. We have no structure in the soil. It's moving down through. And no erosion from this soil, no weeds in our lawn, and no diseases. So huge success stories if you do it right. So James Tillo has been working with Harvard University And all of our university campus has gone biological. Working with Duke, working with Yale, working with all these little colleges on the east coast of the U.S. The only thing that they're using is compost and compost tea. Now that we're working with the landscape department, we're working with the guys who run the ground crews at these universities and colleges. Do not go and talk to the soil science department. Do not talk to the agronomy department because they have no clue what we're doing on their own campus. They ignore it completely. I don't know if you've ever been to university and how you can have a department on this floor and a department on this floor, and they never ever speak to each other. It's no man's land. So sad, but that's how the university goes. So interesting. Well, a few more examples. Going more towards landscape, more towards the kind of smaller scale things that we had before. This is a company in Texas, Sustainable Growth Texas, that I worked with a fair amount in the past. They feel like they've got it all figured out now. They don't really have to talk to me anymore. Okay, fine. They'll leave them. This is a pipeline that they put in. And so dug up on this wonderful, what do you call this stuff, soil? It's sand, it's blow sand, sugar sand is what they call it there. They dug it up, put it in the pipeline. So here we go, miles and miles and miles of pipeline. How are you going to remediate this soil? Look at what they tried starting with. Hydroseeding? Because there's not a lot of money in the state of Texas for remediation projects. They only want to give you enough money to go out and put on one application. And that's it. It's got to work. So tell me, the one application of hydroseed, has it worked? That's pretty sad. All of it is ended up in the places where the wind blows it. Now most of it's down here in the bottom where the creek is. Great. What is this doing to your creek? Please realize that the green dye that they use in hydroseed is toxic to the growth of grass seed. Oh, I love that one when we figured that one out. And it doesn't do much for your biology in the soil either. It's pretty toxic. So they put that hydroseed down. One rainfall event has happened here. Look at the erosion already starting to happen. So after the second rainfall event, pretty soon we're going to be uncovering that pipeline. How do you deal with this in a permanent fashion? Compost, compost tea, but exactly how? Okay, so you got to check your compost and make sure it's balanced fungi to bacteria. You got protozoa, you got nematodes, so they did that. But now you only have one chance, one application here. So what they did was come out with 2 inches worth of compost and blew that compost that they had already put seed into. And they applied a compost tea first thing that morning, brought it out, blew this out onto the property using a snowblower. What's a snowblower doing in Texas? Okay, they get a little snow in there. Covered it off completely. Now I would love to have a picture of what it looked like with 2 inches of compost on top of this, because everything kind of gets smoothed out. They don't do anything about the erosion. That's way too expensive. It's expensive enough blowing the compost and the seed and the compost tea out here. But here we go with 2 weeks later, 6 weeks later. Has this been successful in reestablishing the native system in this part of the world? Yeah. These are the native grasses. Yeah, there's a little weed, so it's snuck in there. But if we come in and do another application of tea, compost, we should be able to move it out of that weedy system. Texas, what are they going to do with grass like this?
Cows.
Cows. You're going to put cows on it. So look at the fence that it's gone in. Because if you've got grass like this, you're going to feed something with it. So all of the PVC pipe, this is not irrigation for the grass. This is water for the cows. There's been no irrigation on this system at all. But now that we're going to put cows in there, okay, we can spend all kinds of money once we start grazing things. So highly successful project. Moving on then to trees. So here we are with a tree that has been inappropriately planted into the soil. Now, so here's the root ball. And look at how it's sitting up above the rest of the soil around it. Poor baby. Compaction, so they just dug a great big hole, plopped the tree in there, pushed the wood chips up next to it, and of course it didn't really last. Washed it. This has been washed out by water coming through the system, but we got a compaction zone on the bottom of that root zone that is really painful. The roots of that tree are not going through that compacted area. The roots are starting to go round and round on the bottom of the hole. How are we going to deal with this? We aren't going to pick that tree back up. That would probably kill it. So instead, taking an injector, pushing that down into the soil and injecting compost tea through that compaction area, making sure that we get punched through that. And so pumping out compost tea all that way up through that cylinder of soil, getting it well inoculated with the organisms. And of course, typically, we're going to try to go halfway between the drip line and the stem of the plant and do the 4 cardinal points, and then go out here to the drip line and do 8 applications, injection like that. We have been able to resuscitate these trees. So this is Ballpark from Brewer Organics that we were working with on this one. Putting the shredded bark then back to help those root systems not dry out. But getting the biology in there so that that shredded bark material stays in place instead of washing away after this. So, lots more I can tell you about that one, but Lotus Land, this is one of the top botanical gardens in the United States. And everything that they do is with compost and compost tea. They've been using a biological approach since about 1995. And these are their roses. They have no black spot. They have no mildew. They have no insect pests. Everything is treated with compost tea. So they water with compost tea and nothing else.
I'm sorry, can I go back to the example of the tree?
Sure.
So with the injection, that was done one application or your 3 applications? Or one?
This is one application because it's pretty spendy. And again, it's a situation where it's a lot of man hours to do this kind of injection. So when you have an orchard of trees, this is probably not really practical. If we had an orchard, probably, because you can see that these trees are kind of just random. Not all of them are in the ground yet either. So in a row of trees, probably what you would do is come in and do an undercutting. You do your weed bar, and along that weed bar you would be blasting the compost tea into the soil as so there's one row of trees, there's one row of trees. So that undercutter bar goes into the soil underneath, out into where your root systems of your plants are. And so you undercut and you inject the compost tea all the way down that row. Typically then we're also putting compost underneath the trees all the way down. And then I would also like to see people start to plant specific understory plant species so we get away from having to use herbicide to take out the weeds around the trees so you don't have to mow it. So we switch things over so it's a lot less expensive and the health of the trees is better.
This might be one of those questions where you're trying to swing at me, but we have a soil profile in an orchard. As dirt moves away from the base of the tree and the roots get exposed, and you have kind of more dirt in the center of the rows, it cuts at an angle lower in the middle and throws the dirt up towards the roots. Is that okay for that one-time use and then applying compost tea?
Yeah, that would be fine. As you're taking that soil from the middle of the row and blowing it back over there, why not also be applying compost tea to the dirt as it's flying and settling? So every little bit of that soil dirt is getting coated with that really good compost tea. And then, could Could you go down the middle of the row and put compost down there, and then when you're blowing all of that over, all of it goes together, and maybe straw, or when you mow, you always blow things that you're mowing from the driving row, you blow that over on top of your tree row, just to help protect that soil from drying out. Or get some understory plants in there. So, you know, most of the understory plants that I've been talking about are all things that tolerate being halfway buried by plant residues or soil or compost, and they just grow up right through it.
What are those injectors? And how they work exactly?
Basically what an injector is just a hollow tube on which you have a pump. So you're going to...
a regular sprayer kind of?
Yeah,
you
it's
just have a
pretty much...
push and you're able to somehow jam down.
Yeah, so some of the sprayers actually put a positive pressure on the liquid in the sprayer, and so it just comes out, and you've got a handle, you know, that you turn it on, and so you get that injector as far down as you want to go, then you open up the compost tea and you let that move into the soil, and then you're just pulling that injector back up. And you can see when it gets to the top that you've got compost tea still coming out. And so you're going to get some good compost tea up around here.
Have you got soil compaction? Trying to get that thing down there?
Yes. Get that injector through the compacted zone. I mean, sometimes it's just not possible. Because, you know, if your soil is compacted more than 300 psi, you're not going to get the injector through there.
Is it a sharp tip?
I haven't seen any that have a drill bit or a tip that will help you push through there. So you go in and you get down as far as you can go, stand there and let that injector run for a little bit so you're getting that compacted area wetted up with the compost tea. It doesn't always work perfectly, but it works most of the time.
When you're spraying, what kind of pressure can you
It's not the pressure that you're pushing the organisms out. It's what speed are they going when they hit the soil particle. That's what kills them. So typically we want to, if you can arrange it, there are some of these injectors that pulse out just water. So now you're putting a lake in down there, so when you inject your compost tea, the organisms are going into the liquid and not smacking up against that concrete wall. Same thing, you know, and we'll talk about this more when we talk about compost tea. It's not the speed that you're blown out of the cannon at the state fair. That's not important. You can tolerate many G's of gravity. When you're blown out, it's when you hit the concrete wall 10 feet away. That's what kills you. So if you can get blown out of this cannon and float through the air and finally come down, you probably manage to survive. Same thing with your microorganisms. So if you've got to inject your compost tea to the top of a 200-foot tall tree, you're going to be spraying it out at 6,000 psi. In order to get the water up there, but the tea is going to get up there and fall on the surfaces of the plant. And they're going maybe 0 psi, 10 psi. So now as you start to come down that tree, you better back off with the pressure, because you don't have to push it up there as high. By the time you get down to you guys sitting there, I better not be spraying it more than maybe about 100 psi. Otherwise, we're going to shred the leaves. And that's fairly detrimental, and your organisms hitting those leaf surfaces are going to be crushed by that pressure. So how do you know if you're spraying at too high a pressure? You're shredding your leaves. So back off. Pretty good indicator that you've got a little too much pressure and you're killing everybody. So watering with compost tea, no problemo. Okay. I think we've been asking questions all along, but I'll kind of take a pause and ask for any more questions, or are we ready to go on to the next section? Looks like we're out. It's a little more, and I'll have to sleep you for lunch.
Are we going to go out and look at the compost? It's right here. It's not.
Yeah, it's not right.
Pardon?
Should we do it now?
Sure, that would be good.
Oh,
Get everybody